Hello students, let us now discuss the combination of parallel plate capacitor. Before this, we defined that parallel plate capacitor in which there are two conducting plates separated by distance d. Area of each plate is A, then its capacity is given by epsilon naught A by d. Now in class 10th, we have studied that resistors may be connected in series or in parallel. In the similar way, these parallel plate capacitors can be connected either in series or in parallel. Before this, the representation of capacitor is two parallel lines of equal height. Not nobody will draw like this. This is the representation of cell. This is the representation of cell, but the capacitor is represented like this. Now in class 10th, you know that if you to have resistors, these resistors are connected in series. If connected like this, these resistors are connected in parallel if these are connected like this. In the similar way, capacitor can be connected in series if these are connected like this, and capacitor are connected in parallel if they are connected like this. Look at this. Similar in the case of resistor, you can see in 10th class, same. The only difference, instead of resistor, now have a capacitor. Now you know that when resistors are connected in series in 10th class, current is same, but potential will be different. In the similar way, when capacitors are connected in series, always remember charge will remain same, but potential will be different. This is the important thing. You have to remember that when capacitors are connected in series, charge will be same, but potential will be. I suppose there are three capacitor capacities C1, C2, and C3. Let us suppose A, B, C, D are 4 points. Now let Q be the charge on each capacitor. So this Q will be same across each of the capacitor. You know that what will be total, since potential is different. So total potential is potential across first, potential across second, plus potential across third. But you drive a relation, which one? Q equal to CV. So what will be V then? Q by C. Put here. If you put, you get Q by C, Q by C1, Q by C2, cancel out. So what will be C? This relation is similar to relation which you drive when resistors are connected in parallel. But in case of capacitor, it is the case when capacitors are connected in series. Clear? Okay, let us solve now when capacitors are connected in parallel. Now when parallel they are connected, potential will be, but charge will be. Let us suppose capacity C1, C2, C3. The charge on this capacitor, I suppose Q1, on this it is Q2, I suppose here it is Q3, but the potential across this combination is connected is V. If it is V, then V will be same in all the three capacitor. Now again, the charge is different, so total will be, that will be total. But again we try the relation Q equal to, if I put here what I get, CV equal to C1V plus C2V plus C3V. V cancel out. What will be C then? It will be C1 plus C2 plus. The result is similar result you get when resistors are connected in series. But here this result when capacitors are connected in parallel. Clear this? So number of numericals will come based. I will give you an assignment to. I have already given to you. Further assignment I will give you. You have to solve. I solve one or two numerical, but always remember the capacity will increase when capacitors are connected in parallel, and capacity will decrease when capacitors are connected in series. One of the numerical, let us solve. Simple numerical. Solve this combination. Find the capacity between A and B. It is given to you 2 microfarad, 4 microfarad, 2 microfarad, 4 microfarad. So we have to find the capacity of the combination. So how you will solve? You can see I call this as 1 point. This is my second point. This is third, and this one fourth. Now 1 and 2 both are connected in, you can see both are connected in series, and series the result is 1 by c is equal to 1 by 2 plus 1 by 4. It is 1 by 2 plus 1 by 4. So when you solve, you get it comes out to be 4. 2 plus 1, it is 3 by 4. So if it will be 4 by 3. So this circuit now becomes, and this is my 4 by 3, and this is 2, and this is 4. Now these two are in parallel. So in parallel it will be 4 by 3 plus 2. So it will be 10 by 3 microfarad. Now this further reduces to 10 by 3. Now you can see these two are connected in series. So final result will be 3 by 10 plus 1 by 4. If you take LCM, it is 40, or it will be 12 plus 10. So it will be 22 by 40. If you take the reciprocal, so answer will be 40 by 20. So this is the way you will solve number of numerical as given. Again, I am telling you, you have to practice as much as you can do. Any doubt you have, please ask me. I will solve your problem, but do more and more practice in solving these numerical. Another numerical based on this capacity that I want to discuss with you. Sorry. Oh. Find the capacity of A and B, total capacity of the circuit. Now the first question arises, what type of capacitor is this one? Whether this combination is connected in series or in parallel. To solve this question, what we did that we connect positive terminal to this side, negative to this side. If it is positive, this positive will appear on this side, since this plate is similarly this plate this side, this plate is positive, this negative is connected, it means this negative will appear to this side. Similarly, this negative to this side, this negative this side. Now when capacitors are connected in series, for example, this is the case when capacitors are connected in series, this side is plus, this side is minus. So plus plus by induction, negative by induction, plus by induction, negative. It means if negative is connected to positive, it means then it is connected to series. Come to parallel. Parallel, if you connect this plus, now this appear plus, this side is also plus. It means plus is connected to plus, negative is connected to negative, then they're connected in parallel. Now you can see in this question, positive, negative, but negative is connected to negative. Positive is connected to positive. It means this is the combination of parallel. This distance will be given to you. I suppose it is D, this is D, and this is D. So for this capacitor, so there are three capacitor, then three combination, positive, negative, second combination, three capacitor, but all these three capacitor are connected in parallel. So in parallel, the answer will be C1 plus C2 plus C3. So answer will epsilon naught A by D, epsilon naught A by D plus epsilon naught A by D. So total capacity is 3 epsilon naught A by D. Another such a question, another for your practice, I give you another question. Find the total capacity of this combination. So you will solve this question. I will give you just a hint that first connected across this positive, then positive across this side will appear, positive to this side, and if you give negative, then negative to this side, again negative, again negative, and again negative. It means instead of 3 there is only how many capacitor? 2 capacitor. This is the only hint given to you. Rest you will solve, and let me tell what will be the answer of this question. So one thing is clear that when capacitor filled with air, then its capacity is given by epsilon naught A divided by D. But when it is filled with some medium, then its capacity is epsilon naught A by D. This is very important. For example, I discuss there are two plates separated by distance D. This half of plate is filled with dielectric of dielectric constant K1 and half is filled dielectric constant K2. Find the resultant capacity of the combination. Now look at clearly. Again, if I give positive, this side will be positive by induction, negative. This side is a negative by induction, it will be positive. It means positive is connected to negative is connected to positive. So this is the case of which combination? Series combination. Now there are two capacitors. The problem is that it is from the center, so half of this distance will be d by 2 and half of distance will be d by 2. So this is first capacitor, this one is second capacitor. Now for C1, answer will be epsilon naught A. Now distance become d by 2, but filled with the dielectric constant, so multiply by epsilon r, or we can say K1. In the similar way, your second is filled with, again, since area of plate, look at this area is same, but there is a problem in distance, multiply by dielectric constant. Since both are connected in series, so answer will be 1 by C1 plus 1 by C2. If you solve, put the value of say, you get epsilon naught A K1 D by 2 plus D by 2 epsilon naught A into K2. 1 by C, you can take common 2 epsilon naught A. Inside you get 1 by K1 plus 1 by K2. And if you take this LCM, so you get हाँ जी बच्चे क्या आएगा, take LCM, you get K1 K2 K1 plus K2. Take its reciprocal, so you get K1 K2 epsilon naught A 2 divided by D into K1 plus K2. So this is the answer. This is the way you have to solve the question. Not a single. I give you another question. You try to solve this question. So write another question. So this again two plates. Now instead of vertical, now half is filled with K1 this side and half is filled with K2 this side. So what will be changed now in this question? First change that instead of series, now they are connected in parallel. Why? Because if you give positive to this side, positive to this side, negative, so positive to positive, negative to negative. Now distance is same. Now in this case what will be changed? C1 is epsilon naught A into K1. Now area will be half. Look at this. उसका half area लिया उसने. Distance remain D. Similarly for this it will be epsilon naught A by 2, K2 distance this. So what is C1 then? If you put epsilon naught A by 2D common, inside you get K1 plus K2. K1 plus K2. So number of numerical beta you will solve. Please try more and more question. Please solve all the question. So it's your hard work that will pay, but keep doing hard work. Another assignment that I give you, that if the question comes that this is again plates, half is filled with K1, this is further half K2, and this half is K3. K1, K2, K3. Find the total capacity of A and P. So these are some of the typical numericals that is given in these types of question. Now I come further and discuss with the energy stored in the capacitor. Thank you.